Okay, so in this video, we're going to continue working with circles. We're going to continue working with the angles um, that are either inside, or today we're also going to move to what happens when angles are sort of outside the circle. So we're going to add one vocab word to what we've been doing, and that's a secant. So a secant is a line that intersects the circle in exactly 2 points. So really, this is if I take a chord, but it keeps going. So if you remember, a chord went from one point on the circle to another point on the circle. This is a secant, so it's a full line that will keep going. So the part that is, say, inside the circle, that can just be called a chord. The whole thing, in this case, line AB, the whole thing is a secant. So anything that can happen with a chord can typically happen with a secant, and oftentimes vice versa, as long as we're focused on the inside of the circle. If you have 2 chords or 2 secants, so again, this is what I'm saying, that they can sort of be interchanged if they intersect in the interior of a circle. So here's picture. So my 2 chords in this case, if they extended beyond my circle, they'd be 2 secants, but they're crossing inside the circle, but this is clearly not the center point. Okay, so that's what's making this different from what we looked at before. It says the measure of an angle formed is 1/2 the measure of the sum of the intercepted arcs of the angle and its vertical angle. And so that's a lot going on. Really what it's saying is if I'm trying to find this angle X, notice that angle X opens up and it makes arc N, okay? But if I go out the other side of the circle, its vertical angle would make arc M out the backside. So really what you're doing is you're using both of those arcs. And so the angle is going to equal 1/2 the 2 arcs added together, the arc that it makes and the arc sort of out the other side. Okay, so in this picture, they want me to find angle 1 and angle 2. So if they want me to find angle 1 is going to equal 1/2 times, and we're going to add the 2 arcs together. So angle 1 makes this 30-degree arc, plus, go out the other side, we have a, sorry for the pop-ups on my screen. If I keep going here, 30 and 40 are 70. And then half, sorry, this should have been a 2 here. Half of 70 is 35. Okay? And so that's angle 1. Then they want you to find angle 2. So notice angle 1 and angle 2 here are next to each other. Angle 2, they did not give me the arcs for angle 2. So what I can do is use the fact that, hey, angle 1 and angle 2 being right next to each other, these form a linear pair. And we've learned about linear pairs before, that linear pairs add up to 180, right? Straight lines are 180. So that means angle 2 is simply if I take 180 and I subtract the 35 degrees that was there for angle 1. So angle 2 would be 145. Okay, so if I look at another one, here's angle 1 and angle 2 again, same premise. Here's 2 chords. The last one was the secants because the lines kept going. The key here is recognizing which angle you can find first. Angle 1 is here, but notice I don't have the arcs for angle 1. I have the arcs that go to angle 2. So find angle 2 first. Nothing says you have to start with angle 1 just because numerically it comes first. So angle 2 is 1/2 the 65 plus the 25. So angle 2 is going to be 1/2. 65 and 25 make 90. And half of 90 is 45. Angle 1, then I'm just going to use my linear pair. So all I'm going to do is take 180 minus 45. And so angle 1 is 135. Okay. So if you have two chords or two secants, they cross inside the circle, but they're not at that center point, then we're using this setup where that angle is going to equal 1/2, and you got to put the two arcs together. One more item, if you have an inscribed angle that is formed by a tangent and a chord, or this could be a tangent and a secant. So remember, inscribed means that the vertex is on the circle. So this is what we're looking at. We're looking at that tangent that just sort of grazes the outside edge. It hits one point. You're looking at a chord or a secant, in this case, right? That starts at that tangent point and cuts through the circle. And if it's a secant, obviously it keeps going. You still have a vertex of an angle that is on the circle. So just like our inscribed angles before, where we had sort of both of those lines going through the circle, the fact that one of the lines is tangent isn't changing what happens. The angle is still going to be half of the intercepted arc. So if we have something on the edge like this, the angle is still half of the arc that is inside that angle, like a Pac-Man. Okay, so that's what we are looking at. In the next video, we're going to move to those angles that are outside the circle.